Turbulent boundary layer. Planetal. Mean velocity distribution for turbulent boundary layer. U by U naught is equal to y by delta whole ratio of 1 by 7. Also called 7th power law. Du by dy y is equal to 0. U naught into 1 by 7 into delta ratio of 1 by 7 into y into 1 by y ratio of 6 by 7. Y is equal to 0. Velocity equation for viscous shear stress. Tau naught is equal to 0.0255 rho U naught square into mu over rho delta U naught whole ratio of 1 by 4. RE 5 into 10 ratio of 5 to 10 ratio of 7. This is U, this is Y, this is laminars, sublayer, this is delta, this is turbulent, this is 1 by 7th power law. Tau naught is momentum integral equation. Tau naught is equal to rho U naught square into curl theta by curl x is equal to rho U naught square into curl y curl x. Integration from 0 to delta 1 minus U by U naught into U by U naught. Tau naught is equal to 7 by 72 rho U naught square into curl theta by curl x. From this equation 3, tau naught is equal to 0.255 rho U naught square into mu over rho delta U naught whole ratio 1 by 4. And this equation tau naught is equal to 7 by 72 rho U naught square into curl delta by curl x. Then delta ratio of 1 by 4 into curl delta integration 0.232 into mu by delta U naught whole ratio of 1 by 4 into curl x. 4 by 5 delta ratio of 5 by 4 is equal to 0.232 mu by delta V naught whole ratio of 1 by 4 x plus constant. When delta is equal to 0, x is 0 implies constant is equal to 0. Delta is equal to 0.371 mu by delta U naught whole ratio of 1 by 5 into x ratio of 4 by 5. X is equal to 0. This one is the graph. Laminar delta is direct proportional to x ratio of 1 by 2. Turbulent delta is direct proportional to x ratio of 4 by 5. Then delta by x is equal to 0.371 over x rho U naught in by mu whole ratio of 1 by 5 is equal to 0.371 over Rex raised to power 1 by 5. Wall shear stress and local skin friction coefficient. Blasius tau naught is equal to 0.0255 rho U naught square into mu by rho delta U naught whole raised to power 1 by 4. Putting value of delta here from 5, tau naught is equal to rho U naught square by 2 into 0.0576 over Rex raised to power 1 by 5, that is 6. Non-dimensional form, tau naught by half rho U naught square is equal to 0.0576 over Rex raised to power 1 by 5, which is CFX. CFX is local skin friction coefficient. Drag force and drag coefficient FD is equal to tau naught into BDS integration from 0 to L. Then is equal to integration from 0 to L rho U naught square by 2 into 0.0576 over Rex ratio of 1 by 5 into BDX. Then X, then L. FD is equal to rho U naught square by 2 into 0.0172 over rho U naught into L by mu whole ratio of 1 by 5 into BL. FD is equal to rho U naught square by 2 into CD into area. CD is equal to 0.072 over RE whole ratio of 1 by 5. RE raised to power 1 by 5. CD is equal to 0.072 over RE raised to power 1 by 5. Drag coefficient, average skin friction coefficient CF is equal to 1 by L integration of 0 to L CF into X into DX is equal to 1 by L integration from 0 to L 0.0576 over REX raised to power 1 by 5 into dx. Non-dimensional form for RE 10⁻7 to 10⁻9 empirical relationship based on experimental analysis given by Prandtl and Schlichting. CT is equal to CF is equal to 0.455 over log 10 RE raised to power 2.58. Velocity increases implies pressure decreases. This one is the maybe the velocity graph. Note open channel. Fluid mechanics, wall shear stress, tau say U, tau to U, then U to UM, UM to Q, UM to HF, shear stress, viscous flow, first viscous flow, second steady state, third uniform flow, pipe flow 2000, open channel flow 5 into 10⁻5 which is laminar, FV plus FV is equal to MA, F is equal to MA, then PA, then P plus curl P by curl X into dx into dA, A is equal to curl V by curl S into ds by dt plus dy by dt, both 0, implies A is equal to 0, putting this value in 1, then F is equal to 0, PA minus P plus curl P by curl X into ds into dA minus tau into 2 pi r into dx is equal to 0, implies minus curl P by curl X into ds into pi r square is equal to 2 pi r into dr, implies minus curl P by curl X into r is equal to tau into 2, then implies tau is equal to minus curl P by curl X into r by 2 if pipe is horizontal. This one is the direction. Tau is equal to tau maximum, small r is equal to capital R, tau maximum is equal to minus curl P by curl X into capital R, tau is directly proportional to small r, z1 z2, tau is equal to minus curl by curl X, P plus rho g z r by 2, which is inclined pipe. This one is the maybe the cylindrical. These are the arrows. Fluid mechanics, open channel flow, then freeboard, the B, this is depth of flow, hydraulic mean depth is equal to wetted area or wetted perimeter, this is B, this is Y, hydraulic depth is equal to A by T, first gradually varied flow, second rapid varied flow, RE less than 500 implies laminar, RE greater than 500 less than 2000 implies transition, FR is equal to V by under root GD. If FR is equal to 1 implies critical flow, if FR less than 1 implies subcritical flow, if FR greater than 1 implies supercritical flow. Flow resistance equation by Chesis equation. This is energy slope SF, water surface slope, then Y, then V, this is rho g Y1, this is B, energy slope SF, A, V, then W, then W cosine and W sin theta, tau naught, P2, D, rho g Y2, theta, WAL, Y2, Z2, Y, then this is the level, SF. This is for the flow resistance equation by Chesis equation. SF is equal to SW is equal to S naught, Bernoulli's theorem, P1 by rho g plus P1 square by 2g plus Z1 is equal to P2 by rho g plus B2 square by 2g plus Z2 plus HF. HF by L is equal to Z1 minus Z2 by L is equal to rho. Component of weight of water, WAL sin theta, resistance to flow, then perimeter is equal to P, length is equal to L, resistance of flow is equal to P into L into tau naught. Tau naught is the Fe square for equilibrium. WAL sin theta is equal to PL, tau naught implies tau naught is equal to W into A by P into sin theta, implies tau naught is equal to W into R into sin theta, implies tau naught is equal to W into R into S naught, where S naught is equal to sin theta. For small value of theta, sin theta approximately equals to tangent theta. F is directly proportional to V square, implies F, capital F is equal to small f V square, small f V square LP. Resistance to flow, small f V square LP is equal to WAL sin theta, then V implies V is equal to under root W by F into under root A by P into sin theta, then V is equal to C under root RS, which implies V is equal to C under root RS. Then Coulter in 1775, C is equal to 23 plus 0.00155 plus 1 by N over 1 plus 23 plus 0.0155 by S into N by under root R. Basin C is equal to 157.6 over 1.81 plus M under root R. Manis equation B is equal to 1 by N into R h by 2 by 3 into S h by 1 by 2. From this equation, V is equal to 1 by R into from two equation and this equation. C is equal to 1 by N into R h by 1 by 6. Economical scale. Most economical sections should have maximum discharge for a given cross-sectional area. Second, minimum exhibition and lining for desired amount of discharge. Third, least battist perimeter so that there will be minimum resistance to flow. Fluid mechanics class. Economical section for maximum discharge. Most efficient R by C rectangular channel and S by C section. Then this depth is equal to Y. B area is equal to A is equal to by, B is equal to A by y, P is equal to B plus 2y, P is equal to A by y plus 2y, dp by dy is equal to minus A by y square plus 2 is equal to 0. Then y is equal to B by 2. Hydraulic radius R is equal to A by B, R is equal to by into by B plus 2y, R is equal to by 2. Most efficient trapezoidal section is theta, this is 1 by n. This is A, this is B, this is y over under root n square plus 1, this is theta, this is y, this is theta, this is ny, this is n, this is 1. Slide slope is constant. Area is equal to by plus ny square. P is equal to b plus 2y into under root n square plus 1. P is equal to a by y minus n by y plus 2y and over under into under root n square plus 1. dp by dy is equal to minus a by y square minus n plus under root 2n square plus 1 is equal to 0. A by y square plus n is equal to under root n square plus 1. B plus 2n y by 2 is equal to y under root 1 plus n square. Hydraulic radius is equal to a by b is equal to y into b plus 2ny over b plus 2y into under root n square plus 1. R is equal to y by 2, sin theta is equal to OA by OC, OA is equal to OC sin theta. In triangle CDE, OC is equal to b plus 2ny by 2, sin theta is equal to y over under root y into under root 1 plus n square is equal to 1 over under root 1 plus n square. OA is equal to b plus 2ny by 2 into 1 by under root 1 plus n square. OA is equal to b plus 2ny by 2 into under root 1 plus n square. OA is equal to 2y into under root 1 plus n square over 2 under by 2 over 2 into under root 1 plus n square. O is equal to y. Condition second, best side's law. dp by dn is equal to 0. d by dn a by y minus ny plus 2 under root n square plus 1 is equal to 0. Tan theta is equal to 1 by n is equal to 1 by under root 3. Tan theta is equal to under root 3. 30 theta is equal to 60 degree. Y under root n square plus 1 is equal to b plus 2ny by 2. Put n is equal to 1 by under root 3. B is equal to 2n by under root 3. Then p is equal to b plus 2y into under root n square plus 1 is equal to 2y by under root 3 plus 2y into under root 1 by 3 plus 1. P is equal to 6y by under root 3. P is equal to 3b since p is equal to 2y by under root 3. Specific energy or specific energy curve T is equal to z plus y plus v square by 2g. Then this is z1, this is z2, this is y. Energy with respect to bed is called specific energy. Specific energy is equal to E is equal to V plus y plus v square by 2g. E is equal to y plus q square by 2y a square is equal to y plus g square over 2g y square. Implies E is equal to y plus q square b square over 2y a square. Q is equal to small q is equal to capital Q by b. Then y E is equal to y is equal to critical depth. Static energy head is equal to y. This is subcritical depth. This is supercritical flow depth. This is E. This one is E minimum. This is T. dA is equal to T into dy. dE into dy is equal to 0 is equal to 1 minus 2q square by 2g a cube into dA by dy. Implies q square T by ga cube is equal to 1. Implies q square by y is equal to a cube by t. Hydraulic depth D is equal to a by t. Then q square by capital A square is equal to g into d is equal to v square implies v square is equal to gd, implies v square by gd is equal to 1, v square by gd is equal to 1, and then taking under root on both sides, under root v square by gd is equal to under root 1, which implies v by under root gd is equal to 1, which is Froude's number. E is equal to y plus v square by 2g. E is equal to y plus v square by 2g. For open channel flow, follow K Subrahmanyan. Depth yc, y2, y1 is equal to y. Critical depth E1. This one is cubic parabola. Then this is graph for Q. This is graph for Q. Then this one is a subcritical flow depth is equal to y plus v square by 2g. Y is the static head. V square by 2g is the kinetic energy head. F is equal to v by under root gd implies 100 is equal to 10 plus 90. Fi greater than 1, 100 is equal to 60 plus 40. Specific energy E is equal to y plus qgb whole square divided by 2g by square. Y b is equal to y plus q square by 2g into y square implies e under root e minus y into 2g y square is equal to q. dq by dy is equal to 0 implies e is equal to 3y by 2. Therefore q small q is equal to gy cube. yc cube is equal to q square by g. yc cube is equal to q square by g. yc is equal to q square by g whole raised to 1 by 3. Then note refer from book. Case channel with pump. Case channel with pump. This one is flow. This is y1, this is yc, this is v1 square by 2g, this is superficial flow, this is delta z, this is e2. E1 is equal to y1 plus v1 square by 2g, e2 is equal to e1 minus delta z, e2 is equal to y2 plus v2 square by 2g, e2 is equal to y2 plus q square by 2g y2, e1 dash is equal to y1 dash plus q square by 2g b square into y1 dash, modified depth, then y1 and y2, then delta z, this is y1, this is y2, this is y1, this is y2. Then subcritical flow with the width constriction, b1 greater than b2, q2 greater than q1. This is b1, this one is b2. e1 is equal to v1 e1. Then this is y. Then v1 square by 2g, v1, then v1, this is v1 square by 2g. e1 is equal to y1 plus v1 square by 2g is equal to y1 plus q1 square by 2g, b1 by 2g, b1 square y1, where q1 square by b1 square is q1. e2 is equal to y2 plus v2 square by 2g, then which is plus q square by 2g b square y2 q2, q square by b square is the q2.